All right, let me compare number 19 and 23. This is the most frequently asked question in the section, and throughout the semester it'll come up quite a bit. This question will keep coming up, and that's okay. It's kind of a strange idea, but I just want to point out why you're seeing what the book has. So the first one up here, first up, it's given to us. Y is solved for, there's nothing more to do. There's really nothing I need to do to the function or anything I need to do to figure out whether it's a function. Just look at what they gave us. So this is what you call a principal root. And basically it's just because I didn't take a square root, it was just there. If this had a negative in front of it, we would only consider the negative values that you would get when you plug a number in for x. Since there's an assumed plus here, as I plug numbers in for x, square and subtract 1, take a square root, I'm just going to consider the positive values I would get out. Now, just to be clear, for example, if I took the square root of 25, my answer is plus or minus 5 because negative 5 squared is also 25. So for example, let's just say I plugged in 3 for x. We're not going to get a really nice answer here, but that would be 9, minus 1 would be 8. So we can certainly break that down. But I'm not looking at the possibility of plus and minus square root of 8. I'm only going to answer with the square root of 8 because I'm looking at the positive version here. That's what principal root means. Now in contrast, when you get to 23, it's not quite fully given to you. You've got y squared here. There's work you need to do to get this thing to be y equals, and then make a decision. So to get y by itself, taking a square root seems like a pretty logical approach. But don't forget, when we take a square root, it could be positive, it could be negative. Because this stuff here squared, if it was negative and you squared it, it would be the positive version. It probably makes more sense with a number than it does with all this stuff in it. But anytime you take a square root, this is the bottom line, anytime you take a square root, it's plus or minus. You've got to put that plus or minus there. So just to kind of use a similar approach here, if I were, I tell you what, let's make this an f of x. So it's a little more consistent with what we were doing in the examples. So let's plug in 3 for x. All right. So plus or minus 3 squared minus 1, that's plus or minus square root of 8. The point is, if I plug in one number for x, which is I plugged in 3, I got 2 things out. That wouldn't pass vertical line test. If I plug in 3 and I get the square root of 8 and negative square root of 8, I'm getting 2 outputs. That's not a function. So this one, 19, is a function. Just put that up there. Yes, function. Because you're only looking at the positive values you get out when you take that square root. 23, not a function, because I've got to consider I've got to take a square root, which leads to plus and minus possibility, and any x I plug in, I'm getting 2 possible answers for y. 63 comes up pretty often as a question. There's a few weird things going on. Number 1, g of y. Just get used to seeing different letters. One, to name functions, g, f, g, h, those come up pretty often. Y as an input is kind of weird, but I think they're doing it here just to kind of get you away from domain is x, range is y. They're kind of mixing it up on you to make you think about, all right, wait a minute, what's going into this function? So in this case, y is an input, which makes it a domain. And we're going to see what we get out. They don't really name the output here, but it's probably not y because y is our input. So I think they're mixing it up just to get you, just to shake you up a little bit, get you out of thinking domain's always x, y is always range. So again, assume it's all real numbers, your domain here. Assume it's all real numbers unless we got a reason to think otherwise. Well, 2 things right off the bat. It's a fraction. I can't divide by 0. If you divide by 0, you get infinity. But that's not an answer, so does not exist kind of works too, because infinity doesn't exist, but that's another topic for another day. But the point is, I can't divide by 0. So, if the stuff down here, which is square root y minus 10, if it's equal to 0, we got a problem. So I'm just going to say it can't equal 0. That's a simple way to do it. So that's one thing we got to consider. The other thing we got to look at is we've got a square root going on. So we know the number that's under a square root cannot be negative. So y minus 10, by the time you plug a number in for y, it is a single number once you condense it down, simplify. But the stuff under your radical, it can't be negative. It can be 0. It just can't be less than 0. So greater than or equal to 0, and then we work that out. So y is greater than or equal to 10. That's not too bad to do. Over here, it's not too bad, just a few little steps here. So let's square both sides. And you can keep that same doesn't equal symbol, that's fine. And we'll move it over there to 10. So y doesn't equal 10. So if you remember and statements back in the day, probably algebra 2 level, y is greater than or equal to 10 and y can't equal 10. So your final answer for the domain, you got to make sure you combine both ideas. You got to answer with the stuff that fits both categories. Not real complicated here. You're just saying that it's everything bigger than 10 except it can't equal 10. So y is greater than 10. That's your domain. That's your answer.